Hello and good morning everyone, and thank you for joining our Nutanix webinar today. So we have Trevor Kelly here from Nutanix who will be presenting today, and then we also have Stuart Curry from Bytes who will just be briefly talking about the relationship between Bytes and Nutanix.
So thank you, Amy, for that intro and welcome everybody. So I've got a couple of slides at the beginning before we get into the main content of what we're here today to learn about in terms of the technology offering. But first of all, I just want to give you a bit of an insight in terms of who Bytes are and where we've come from. Most of you are aware of Bytes as a business in the UK focused on software licensing. Over the last few years, we've diversified into a bigger organisation and better organisation outside of licensing, and stealthily we've launched sort of an infrastructure play as well as a cloud collaboration service too. But about Bytes as a business, we're located in the UK, as you well know, but the bigger picture for Bytes is across the EMEA. We're part of the Altran Group, a 2.3 billion business based out of South Africa, where we share a lot of their services and back-end resources across the group of companies. We are certainly in the UK number one for Microsoft, but over in South Africa we're an infrastructure partner, a systems integrator over there, and we have a lot of tier one core accreditations with the main vendors too. Amy, do you want to move on to the next slide, please? So really our core four pillars of focus in the UK are software licensing and software asset management, which you well know us for to date. But the two other core areas are data center infrastructure and cloud services. Data center infrastructure is based on our core tier one vendors for compute, networking and storage, virtualization and backup. And to complement that, as the market emerges into sort of a cloud-based computing organization, we certainly partner with the likes of Microsoft Azure, VMware with their vCloud Air, and Amazon Web Services too for cloud services. And that kind of brings me on to sort of what is our proposition as Bytes as a business. You know, over the last 10 years, we've seen a lot of change in the market, where we've come from a defined on-prem solution to managed services, now merging into more of a hybrid platform where people are looking to embrace cloud where they can with certain applications, putting them up into a cloud somewhere, but also keeping their core applications on-prem. And certainly the challenges we see around that for on-prem is things like application availability, application performance, you know, complex management solutions where people have different architects for different type of technologies and solutions. Rack space seems to be a premium for a lot of people these days, spiraling support costs, and obviously things like data copy. So what we're tending to see now with most of our customers is a concept called hybrid cloud, where people are starting to understand and look at, well, how can I move my applications from an on-prem environment up to a cloud quite easily and seamlessly, and bring it back down to on-prem as and when I need to. And so really the purpose of this webinar is for me to pass over to Trevor Kelly, who will explain more around Nutanix, the concept of hyper-conversion, how that can address some of those pain points that I've just touched on. So Trevor, over to you.
Thank you very much, Stuart. Let me just click on the button that says share my screen. Hopefully you can see some slides. Yes, I can see that you can. Thank you very much. That's brilliant. So I am Trevor K. My title is Systems Engineering Manager for Western Europe for Nutanix. Western Europe is quite an interesting term in Nutanix because it encompasses UK, Ireland, and sub-Saharan Africa. So yeah, I'm not sure if that's quite Western Europe. That's the way we define it. So I'm going to spend sort of 20 to 30 minutes talking about hyper-convergence, specifically in Nutanix's approach, and clearly there's a Microsoft element to this as well, and I think you know, what's exciting for me is that Nutanix has got a great relationship with Microsoft. At our end user conference back in June last year, We had 1,000 people in the audience, and it was our very first one, but Microsoft were on stage with us for the keynote speech. So, you know, pretty much everything we do is fully supported with Microsoft, and you'll see that as we go through the presentation. You know, Nutanix works in a server virtualized environment, so clearly we work very closely with VMware and ESX. We've also got our own hypervisor, but Hyper-V is fully in there as well. So I'll cover some of that as well. The first slide I want to move on to, I'm not going to talk about, is that going to move? I've pressed the button and nothing happened. Let me try again. Here we go. So I'm not going to specifically talk about Henry Ford, but I think you can see the sentiment here. And the thing, you know, if I talk a little bit about my experiences and, you know, and some of the reasons that I joined Nutanix, you'll understand, you know, why I put this quote up from Henry Ford. Right, what we're seeing is a real shift in the industry from a very traditional way of doing things to something that's much more software defined. Now, I've spent pretty much all of my career selling storage and external storage arrays. I worked for Threetier for 7 years. Before that, I worked for Veritas Software. I've spent the last 4.5 years before joining Nutanix working at HP. And those organizations are really still selling that three-tier type architecture. And so when I talk about three-tier, I mean server, storage area network, and external storage arrays. And what we're doing with the software-defined approach is really collapsing that into a single platform. And the design principles really come from the likes of Amazon, Google, Facebook, those sorts of organizations. You know, when they started out, they looked at the way that you know, the normal IT infrastructure was designed and architected, and felt that actually for the scale that they're going to work at, this is going to be a bit of a challenge for us to manage. You know, you can scale to a few users, but when you start building out these hyperscale type data centers, then it becomes a real challenge to manage that. So they've taken a very much of a, you know, we use industry standard x86 servers with some disks built into the server, and we use some clever software to produce the same sort of services and resilience that you'd expect in enterprise data centers. So, you know, what Nutanix has done is taken that software-defined Webscaler type approach and made that commercially available. And I would say that, you know, we're fairly unique in the marketplace for doing that as well. So this has been validated by Gartner. This is the Magic Quadrant of, from August last year. And as you can see, Nutanix are at the most visionary in the top right-hand side. And as you can see, all the other vendors are the traditional three-tier type architectures. And I think what Gartner have recognized exactly where Nutanix are in the marketplace, really out there pioneering this software-defined type data center model. So let me get into the technology and try and give you a bit more of an understanding of how this works. I've already spoken about you know, Amazon, Facebook, Google, those sorts of platforms, and really the design point for Nutanix are really these organizations and the way they've approached their infrastructure. And we use the term, Nutanix uses the term invisible infrastructure. So the idea is that this is very straightforward and simple to manage and to expand and to provision services, that it's almost invisible. So really that's our vision going forwards, and I'll delve into that in a little more in a little while. So the design point for this invisible infrastructure, really, you know, there are two elements to this. One is web scale engineering, and I'll talk about what we mean by web scale engineering in a second, and consumer grade design. So we've or Nutanix engineering have spent a lot of time focusing on the usability of its product, and what I'm hoping to do is show you a little bit of a demonstration so you can see how simple and straightforward it is to, you know, manage this infrastructure. And the great thing about this is that you, with the hyper-converged approach, you can do everything from a disk firmware upgrade or even a server BIOS upgrade right the way up to provisioning virtual machines from a single graphical user interface, and I think that's also unique in the marketplace. So let's talk just quickly about Webscale infrastructure. Okay, you can see around the outside. So this is again Amazon, Google, Facebook. In fact, one of the founders of Nutanix was the lead engineer on the Google file system. So you can see where the concepts of this technology came. So the first is that we can see hyper-converged on x86 servers. So we're using standard x86 servers with embedded storage, and that is the hardware platform. So instead of the three-tier architecture where you have your servers and you have your external SANs and your external storage arrays, it's purely just the x86 servers with embedded disk drives. The concept is that you've got all the intelligence in the software, and the other thing about Webscale is that everything's distributed, so all the tasks is completely distributed across the cluster. So the concept really is that even though you might have 50 nodes in a Nutanix cluster, right, it's acting as a single system, so everything is distributed evenly across that. And if you've heard of some of these underlying architectures like Zookeeper, Cassandra, I was just trying to think of the other one, but it's gone out of my way. And Curator, so Curator, Zookeeper, Cassandra, those sorts of things that are used in these Webscale technologies, we're using the same underlying architecture to really distribute the workloads across the system. What that means, actually I'll come back to that in a second. So all intelligent software. And the idea is that we're using the clever software to create this single system in a cluster that's completely self-healing. So if you take the hyperscale data centers, they're expecting disk drives and memory DIMMs and CPUs to fail all the time. So the concept is that you just carry on working if we get a failure. And the other thing from an automation perspective is that we're using API-based automation, rich analytics. We've got full RESTful API built in so that you can integrate with other types of automation tools or build your own automation tools around this. So what this means, right, is that on the left-hand side we talk about scale without limits. And I talked about very large data centers, but this does scale down as well. Our minimum configuration are 3 nodes or 3 servers, and then you can scale linearly from that. And the great thing, it is linearly. So Nutanix is quite well known for VDI, and one of the reasons is that you don't end up with bottlenecks for your storage. So the idea is if you have a single server that might be able to host 100 desktops, if you've got 10 servers, it will host 1,000 desktops because of the way that the technology scales linearly. Fractional consumption, what that means is you can start out small and you buy as you need it rather than buying great big chunky storage arrays or a blade chassis. If you need some extra compute, you just drop a small amount of extra compute in there and the system grows in that way. We've talked about self-healing, and the concept is it is always on operation. So everything we do through the most basic firmware upgrades to hypervisor upgrades to migration to new hardware platforms, we can do that all online without having to take anything down, and we try and automate as many of those processes as possible. And really what this leads to is a much lower total cost of ownership, and I'm hoping you'll see that through the presentation as well. So here's the first part of the comparison. On the left-hand side, I've talked about the 3-tier architecture. We've got servers connected to some sort of storage network and then connected to an external storage array. And if you just think about the number of cables and connectors that are required and the components that are required on the left-hand side just to put that environment together, leave alone the fact that in many instances you'll have three vendors, different technologies in there. Quite often the storage array is different to the storage area network is different to the server platform. So you've got different technologies, different companies that you might be working with, and lots of hardware and connectivity. On the right-hand side, we're using standard x86 servers with embedded storage, and so from a hardware complexity perspective, it's far simpler, and quite often that means that we need significantly less rack space to deploy a solution. So one of the customers that we're working with, they are a Microsoft customer. In fact, they talk about going from 18 racks of their traditional Windows estate down to 2 half racks of Nutanix to run their complete infrastructure. So that's sort of a 9-to-1 ratio if you consider it in racks. And then the quite interesting thing is that I've spoken to several customers, and that ratio of 9-to-1 I've heard before from other customers to saying, well, we had 9 racks and actually we shrank it down to a single rack. So that's the sort of physical consolidation that you might expect with Nutanix as well. And actually one customer was considering, they were using Colo for their DR site, and they were actually considering, well, let's not do that. We've got several buildings around the UK. Well, let's just use a comms cupboard in there and put our DR site in there. So that's a different way of thinking about how you deploy your compute environment. So this goes into a little bit more detail in terms of how the technology works. You can see here on the top we've got 3 separate nodes, as we call them, but effectively they are servers with embedded disk drives in them. So you can see it's compute and memory. Normally they're dual socket CPUs, memory typically up to 512 gig of RAM. We have got one node that will go up to 768 gig of RAM. And typically we'll have 2 SSD drives in there and 4 hard disk drives. There are different models, and I've got a picture to give you an idea of what the physical hardware looks like as well. There are different models, so you can scale the cluster either in a compute fashion or a storage fashion or a balance, depending on your requirements going forwards. So, and I'll say I've got a picture to discuss that. So standard x86 nodes with storage embedded, and effectively we're running a standard hypervisor. So on this cluster you'll be either running VMware ESX, you'd be running Microsoft Hyper-V, or we call it the Acropolis hypervisor, which is the Nutanix hypervisor, which is based on KVM. You can see at the bottom right it talks about KVM, and effectively what we've done is productized KVM and made it enterprise ready. So there's standard hypervisor in there, and we have this thing called a controller virtual machine. That's the CVM. So every node will have a controller virtual machine running in its server virtualization environment, and that's where really all the intelligence for our technology is. What this means is that for the virtual machines that are running your applications, they connect to the storage through that controller virtual machine. So you can see on the right hand side we've got the virtual machines accessing its storage through the controller virtual machine. And what the controller virtual machine does is it effectively creates a pool of all of the disk drive that's connected in all of the servers. And so a good example is that when a virtual machine writes into its storage, the controller virtual machine will automatically replicate that to at least one other node in the cluster to provide you the level of resilience. And clearly, when you read, we try and keep the data local to the actual server, and hopefully you'll be reading from the SSD, if not the local disk, and there'll be occasion when you need to drag data over the network and read data from another node in the cluster. But that's the idea is that level of complexity is completely hidden through this controller virtual machine. And there's other advantages of doing it this way as well, because if you have a controller virtual machine fail for whatever reason, then the virtual machines that are running don't go offline. They just connect to another controller virtual machine that's out on the network. We do say, one of the enabling technologies for Nutanix is 10 gig Ethernet. You can run this with 1 gig Ethernet and it works fine. However, that soon becomes a bottleneck. So we do suggest 10 gig Ethernet between each of the nodes in the cluster. Especially, if these are quite active virtual machines, then they will be, we're always replicating data over to other controller virtual machines. We talk about in the Senate it talks about performance and data localization. That's one important feature for us, is that if you migrate a virtual machine for this right hand node, perhaps the one in the middle, then what we'll do is we'll also migrate the data that it's using to try and keep the data as local as possible. And that works really, really well with solid state disks. So the latency that we get to solid state disks is excellent, especially compared to those traditional 3-tier architectures, because we're not dragging the data over a storage area network and behind a pair of controllers. Also, the final thing I want to mention about this is that the controller virtual machine has all of the functionality you'd expect in enterprise storage arrays. So you can see we've got snapshotting in there, replication, we've got deduplication, compression. So there's all the functionality that you'd expect within an enterprise class storage array. So that gives you a little bit of an idea of how the architecture works, and I just want to talk a little bit more about what that really means. So in the traditional environment, you need a network to connect to the outside world. You've got servers, you've got some storage, and optionally you perhaps have a fiber channel storage area network, and that's typically your physical infrastructure. On top of that, you have your virtual infrastructure, and with your application sitting on that. Now, from a Nutanix perspective, clearly we still need a network to talk to the outside world, but we're really collapsing, the architecture on the left. So, in a single platform from Nutanix, you get all your compute and storage needs. And then from a virtual infrastructure perspective, we support, as I said before, ESX, Microsoft Hyper-V, and our hypervisor, which is based on KVM, which is the Acropolis hypervisor. And what we've tried to do with this is we tried to provide 80% of the features of ESX, the features that customers use on a regular basis. We've built that into our graphical user interface. We provide enterprise class support around that. So effectively, this is not KVM, this is the Nutanix hypervisor. And so if you look at that on the right hand side, actually let me just add the app layer here. So from an application layer, you've got the situation where you run your application. If you're running on the Acropolis hypervisor, everything is Nutanix, which really simplifies the stack. From a support perspective, you're speaking to one vendor for the complete stack, from the hypervisor down to the storage component. Let me just talk a second about Microsoft here as well, because clearly, Microsoft there from a Hyper-V's perspective, we've got loads of customers running Hyper-V on Nutanix, and it works really, really well. It's fully supported by Microsoft, but clearly we've got our own hypervisor as well. And Microsoft we're fully supported with the Microsoft relevant programs for our Acropolis hypervisor. So the server virtualization validation program, the Acropolis hypervisor is supported there. We also have, we've worked with, and from an application perspective, then the Microsoft applications are all supported with the Acropolis hypervisor. So in a Microsoft environment, you'd either choose to run Hyper-V or you could run Acropolis, and your applications will work just as well on either. We've got reference architectures for things like SQL Server, Link, Exchange, and part of the ESRP program for Exchange. So we've done everything we possibly can from a Microsoft perspective to make sure everything's fully supported with full reference architectures. What I also say on there is there's a couple of other vendors that I'll mention that we've got some really good relationships with. The one is SAP. So Nutanix are the first hardware platform in 6 years to be certified by SAP, and certainly the only hyper-converged platform. And the other one is Citrix. So Citrix have completed certification. We've completed certification with Citrix on our Acropolis hypervisor. So you can sit Citrix on a complete Nutanix platform to really simplify, the management and also the support of that infrastructure. And again, the idea is that we make this as simple and as invisible as possible. Let me just talk very briefly about the journey to the invisible infrastructure. So this is our vision, our plan. The idea is we make storage invisible, virtualization invisible. Now that's an interesting concept, and you'll see in my next slide. Because we support these 3 different hypervisors, our next step really is to be able to migrate workloads between any of those hypervisors, and then into making cloud invisible. And we do this with we call it the extreme computing platform, and there's 2 technologies in here: Acropolis, which is the underlying infrastructure and file system, and Prism is the management interface. I'll drill down to this a little bit more. Also, there's a really good point here to mention that Nutanix, even though it's a software vendor, right, we only support certain hardware platforms, and there's a really good reason for that. It's really about customer experience, to be able to build in pictures of the hardware into our GUI, to be able to do BIOS upgrades, to do firmware upgrades. We really need to understand and work very closely with that hardware. The other thing is, if you're running an SAP or Citrix application or Microsoft application that sits on Nutanix, then clearly we need to provide really good support for that, because because we're providing that complete infrastructure. So the hardware platforms that we support are listed at the bottom there. If you buy a solution from Nutanix, then we provide you with super microservers. We've been working very successfully with those guys for some time. Dell also OEM our solution is the XC series from Dell. So if you buy XC from Dell, it comes with Nutanix loaded onto it. And the Lenovo is the most recent announcement. Their HX series, again, is the same. If you buy the Lenovo HX, it comes with Nutanix as part of that solution as well. So we've got some really good routes to market there, and most customers are quite happy with that approach. And so you can see here that we talk about Acropolis, right? So Acropolis really is the infrastructure piece. It consists of 3 components: the distributed storage fabric. So this is really the marketing name for that controller virtual machine. So that's where all of the storage services, the data replication, snapshots, etc., all built into the distributed storage fabric. We've got our own hypervisor, which we call the Acropolis hypervisor. Again, that's based on KVM. And the application mobility fabric is something that we're just starting to release with the latest release of our software. And this is the ability to take workloads and migrate it between any of those hypervisors. So the idea is that perhaps you're running ESX and you like the idea of running Acropolis, especially as Acropolis comes with our platform, you don't have to pay any licenses. Then you can migrate that with a single click of a button across to Acropolis. So that's the idea of the application mobility fabric. And moving forwards, Prism is the management side of things. I'm looking at the time and I haven't got a huge amount of time, but I'm going to spend just a couple of minutes just doing a demonstration of a Prism, and you'll see how straightforward it is. But one point I make here is that the idea is that we try and make it one-click, planning, provisioning, remediation, upgrade. So an example is that if you need to do a hypervisor upgrade, you effectively point Prism at the ISO image, and the system will automatically do the upgrade in an online manner. So what that means is it targets a single host, migrates all the virtual machines across, upgrades that host, migrates them back again, moves on to the next host. And so that's completely automated under the covers. You don't need to do that manually, to sort of simplify that. So that's the Prism component. The idea going forwards is that we extend that into cloud services. So you can see we've got AWS and Azure that's listed on this slide, and will include other cloud platforms as well. And we're just starting to do some work with containers now. We've got support for Docker and the reference architecture that we've just released as well. So the idea is that we extend that into the cloud, and you can decide where you want your application to run. And actually there's a very good example of a customer of ours, and they are a complete Microsoft shop, and what they've done is they've actually sized their on-premises private cloud. Effectively, I think they're using it's the fast track for Azure cloud. They've sized that for 11 months of the year. And they've got 1 month that's particularly busy, and effectively what they do is they burst out into the cloud for that 1 month and then come back again for the rest of the 11 months. And they're also using Azure for DR and backup. So the idea is they've got their private cloud running on Nutanix, and everything for DR, backup and bursting they do with Azure as well, and that's a complete Microsoft platform. So all that sort of stuff's real and starting to happen now. So I guess that's talking about futures. Just spent a minute or so talking about hardware platform. So this is an example of one of the, we call it a block, A block really describes the tin around the outside and a couple of power supplies. This shows a block, this is a Supermicro server or servers that has 4 servers in a 2U footprint. Okay, so it's very, very dense. Each one of those servers is dual socket, up to 512 gig of RAM, as I mentioned before. They've got dual 10 gig NICs in there, and some of them are expandable to 4 as well. So these are, very, very powerful little platforms. At the top you can see, in fact, if you look at our website and then look at hardware, you can see the various different platforms there. But this is an example of a 3000 node that I show at the top. So the diagram shows 4 nodes in 2U, and we have different nodes depending on your requirement. So the 1000 node is sort of an entry-level version of the 3000. 3000 works really, really well for VDI type environments where you need high performance storage and you need high performance compute. So that's a really good balance. The 6000 nodes are storage heavy, and in fact there is a 6000 variant that has storage only, so you get 30 terabytes of storage and enough compute just to run our controller virtual machine. So for example, if you expand your cluster, if you just need more storage, then you can add a 6000 node to that. And things like 7000 node is you can add GPUs into there for the graphics display. The 8000 is much more CPU intensive node, and the 9000 is an all SSD node. Typically what we have is a combination of SSD and hard disk drive, and we automatically tier the data between those. So that gives you a little bit of flavor for the hardware. Dell have been OEMing the Nutanix solution for just over a year now, and their hardware offerings are pretty similar to Nutanix. And Lenovo are just starting to release their platforms at the moment, so they have got a good range of platforms, but perhaps not quite as rich as Dell and Nutanix at the moment, but that will certainly change. Good point just to make here are the types of applications that were suitable. If you can virtualize an application, then you can run it on a Nutanix. Okay. When we started out selling this product 4 or 5 years ago, then VDI was a very, very good use case for us. But as you can see here, you can run business applications, enterprise databases. We've got loads of customers running, SQL Server, Oracle, SAP. And big data with things like Splunk and Hadoop there, and again unified com. So you can see that this is a general purpose type platform that can run pretty much any workload. So what I'm going to do now is I'm just going to spend a couple of minutes just delving down into the interface so that you get a little bit of a flavour. And the idea is this consumer-based simplicity. Right, I just need to dial into this quickly. I'm hoping you can see this. Why is that not? A second, I seem to have lost my login. Let me just get that. There we go. This does time out after a few seconds. I had it logged in a second ago, but just bear with me a second, please. Just being very careful typing my password in, make sure I get it right. So this is, I'm just using a web browser, and we're connected using HTML5 to one of the controller virtual machines in the cluster. So effectively you can connect to any controller virtual machine in the cluster. It has exactly the same view of the cluster. This is the base home screen. On the left-hand side you can see which hypervisor this is running. So this is our Acropolis hypervisor. The amount of storage, we've got 71 virtual machines on here, and from a hardware perspective we've got 4 hosts in a single block. In the center here you can get some idea of the performance. So we've got quite a lot of workload going on the system. It looks like it's running at 29,000 IOs a second. Just over 100 megabytes per second as well. It shows pretty decent latency for the storage, so it gives you an idea of the performance. and from a health check perspective, it's looking okay. There's a new version coming out in a couple of weeks, and that has you can set up this dashboard to how you want to see it, and also create views of particular services or applications. So you group your virtual machines by a service, and then you'll be able to look at the view from there. Take a very quick look at your view at the hardware. So if I drill down into hardware, and then we get a diagram view, you can see what this block looks like. So we've got 4 servers in here. Each one, in this case, they have 5 disk drives in there. You can drill down into any of the individual components and look at that usage. Disk performance, does that show it's doing anything? No, that's quite quiet. On the other one, so I guess, is this one the SSD? So this is an SSD running at the 280 odd IOPS, so that's just ticking over really. And the same with the servers. You can drill down into servers and look at the performance for the particular individual servers in there. So that gives you a very straightforward view. This is going to be interesting. I just need to get over here a second. From here, I just wanted to show you things like software upgrade. So to do a software upgrade, you can see we can do everything from a disk firmware upgrade here. I think we've got there's a BIOS upgrade that's available for certain versions as well that would be automatically populated here. Again, I talked about hypervisor. You upload the hypervisor binary, click upgrade, and it will do everything it needs to upgrade that. The Acropolis is effectively the controller virtual machine, and NCC is Nutanix cluster check. So this is a, if you start running into problems, you run that and it will give you a health check of the system. Okay, let me just see if I can move this and go back the other side. So that was the hardware side of things. I'll very quickly show you storage. So from a storage perspective, it's pretty straightforward as well. You can see we've got 12 terabytes of storage free in the system. Effectively, there's one construct that you get involved in that's called a container. So a container ends up being a data store that you'd use for your application. So for example, if you deploy Exchange on Nutanix, you might say, well, I'm going to create a specific container for that. You'd give it a name, and there's some advanced options here. You could give it a name and hit save, and that's all you need to provision. But there are some advanced settings, and I give you some idea of what that means. So replication factor, by default, when you write into a controller virtual machine, we replicate to one other node in the cluster. You can change that to 2 nodes in the cluster. So if you've got an application that you're quite paranoid about, you can replicate that twice. Erasure coding is a method of, we are replicating to another node in the cluster. That's written to solid state disk. When we destage that down to a hard disk, we can write it in effectively a RAID 5 format, which frees up a lot of storage capacity. You can reserve a certain capacity for an application, so if you definitely don't want an application to run out of storage, no matter what happens, then you can reserve some, you can advertise a certain amount, and then you can build things like deduplication and compression in there as well. The idea is that we'll make this simpler going forward as well, because things like erasure coding and deduplication and compression are capacity optimization techniques, and the idea is going forwards we'll look at the incoming workload and the way that's laid out on disk and automatically turn on the relevant capacity saving algorithm, so you won't need to do that. But as you can see, from a storage perspective, that's all there is to manage. So there's no RAID management, there's no creating of LUNs, there's no LUN masking, all that sort of stuff. None of that exists. You purely create the container and present it, present the container up, which is seen as a data store. The final thing that I wanted to show you is from actually 2 things, from a virtual machine perspective. So everything I've shown you so far is identical as to whether you're running ESX or Hyper-V or the Nutanix hypervisor. The only difference, as you can see here, we can see a number of virtual machines. This gives you a list of virtual machines. Really the only difference with the Acropolis hypervisor is you have the ability to create a virtual machine. Okay, so if I create a virtual machine, you give it a name, an amount of compute, some memory, some disk, hit save, and that creates your virtual machine. If I go to one of these virtual machines, we also can see here that we have things like launch a console. You can power it on, take a snapshot, migrate to another node in the cluster, pause it, clone it, update it. So all the standard stuff that you do with a hypervisor you can do from within this single graphical user interface. That's very, very straightforward. The final thing that I'd like to show you here, which I think is, a very powerful thing that really shows you the power of hyper-convergence, right, is that at the top here you can see alerts, and you can see from end to end. Okay, so we see alerts and events in the system, and you can correlate them to other things that are happening within the system. So this is an example here. I can't see because I've got a window in the way. I apologise for that. But you can see we've had an alert, and that's followed by an increase in disk IOPS and an increase in memory usage. And you can actually add lots of new entities into this as well, or lots of metrics and charts into this. So, from things like the way the cache is being used, disk bandwidth, how the hypervisor is using the system, you can add into this single timeline. And so it's very, very straightforward to do an analysis of the system. So, hopefully that gives you a feeling for, how simple and straightforward this is to manage, especially if you look at it from a storage perspective. In our next few releases, you'll see that simplicity and ability to migrate workloads between hypervisors, making working with the hypervisors just as simple as well. I think that's questions out there.
Sorry, Trevor, we just I think you just cut off at the end.
Oh, okay. So I'm just saying that.
Finishing up.
Yes. So was the demonstration? Did you manage to see the demonstration? Okay.
Yeah, I saw that all fine. I just literally lost a couple of seconds of audio there.
Yeah, I can see one question here that says, question for Trevor, what technology do you use to move data applications to and from Azure? So at the moment you can do DR and snapshotting, and effectively snapshotting your virtual machines into Azure. We call that Cloud Connect, and that is part of the Nutanix solution. We don't use another technology to do that. We have shown demonstrations of moving virtual machines into the likes of AWS and Azure, but I don't know the details of that technology. That's not something that's released today. We can do the DR quite happily today and back up, and that's using our underlying technology. Moving a virtual machine and moving a workload into something like Azure is a little bit more complex from our perspective, because there's a lot of network considerations. So there's a lot of magic that needs to happen from a networking perspective that I don't have the details of yet because we haven't productized that piece. Having said that, Microsoft with its Azure program are doing similar sorts of things. So the idea is that we'll be able to do this in Nutanix, but from an Azure perspective, then you can use all the standard Azure tools as well. So I think there's a choice there. I'm hoping that answered that question.
Thanks, Trevor.
So are there any other thoughts or questions, Stuart and Amy, before I finish this?
Okay, we don't have any more. I think that's it for today. So if I just take the screen back for a second. So Trevor, thank you for presenting today. And also everyone, thank you for joining and taking the time out of your busy schedules to watch the webinar today. So if you do want to submit any questions outside of the webinar, there's an email there, so tell me more at bytes.co.uk. Or if you'd like any more information, if you could just pop that in the feedback form at the end, that'd be great. Okay, so thanks Trevor, and thanks again everyone for joining.
Thank you very much for listening.